Top 30 Network Engineer Interview Questions and Answers. Explore our expertly crafted guide on the top 20 network engineer interview questions and answers, designed to help professionals excel in interviews with concise, technical insights for success. 1. What is the OSI model? Explain each layer briefly. The OSI model is a conceptual framework for understanding network communication, divided into 7 layers. Physical layer transmits raw bits over hardware, cables, hubs. Data link layer ensures error-free data transfer between adjacent nodes, MAC addresses, switches. Network layer manages logical addressing and routing, IP routers. Transport layer provides reliable data transfer, TCP/UDP. Session layer manages sessions between applications. Presentation layer handles data formatting and encryption. Application layer supports user applications, HTTP, FTP. 2. What is the difference between TCP and UDP? TCP, Transmission Control Protocol, and UDP, User Datagram Protocol, are transport layer protocols. TCP is connection-oriented, ensuring reliable, ordered data delivery with error checking and flow control, ideal for applications like HTTP and email. UDP is connectionless, prioritizing speed over reliability, with no error recovery or sequencing, suitable for real-time applications like video streaming or gaming. TCP has higher overhead due to handshakes and acknowledgments, while UDP is lightweight but less reliable. 3. What is a subnet, and how do you calculate subnet masks? A subnet divides a larger network into smaller, manageable segments for efficiency and security. A subnet mask determines which portion of an IP address represents a network and which the host. To calculate, convert the mask to binary, e.g., 255.255.255.0 equals /24, meaning 24 bits of network. For subnetting, borrow bits from the host portion, increasing the mask, e.g., /24 to /26 creates 4 subnets. Use binary math or subnet calculators for precision. 4. Explain the difference between IPv4 and IPv6. IPv4 and IPv6 are IP addressing protocols. IPv4 uses 32-bit addresses, e.g. 192.168.1.1, supporting 4.3 billion addresses, now depleted. IPv6 uses 128-bit addresses, e.g. 2001:0 db8, offering vast address space. IPv6 eliminates NAT, supports auto-configuration, and includes built-in security, IPsec. IPv4 relies on decimal notation, while IPv6 uses hexadecimal. IPv6 improves routing efficiency and header simplicity, but isn't backward compatible with IPv4, requiring transition mechanisms like tunneling for coexistence. 5. What is ARP and how does it work? ARP, Address Resolution Protocol, maps IP addresses to MAC addresses in a local network. When a device needs to send data, it checks its ARP cache for the destination's MAC address. If absent, it broadcasts an ARP request. The device with a matching IP responds with its MAC address. The sender updates its cache and uses the MAC for data transmission. ARP operates at the data link layer, essential for Ethernet communication. 6. What is the difference between a router and a switch? A router operates at the network layer, directing traffic between different networks using IP addresses, performing routing and NAT. A switch operates at the data link layer, connecting devices within a single network using MAC addresses, forwarding frames based on MAC tables. Routers handle inter-network communication, while switches manage inter-network traffic. Routers are more complex, supporting protocols like OSPF, while switches focus on fast, local data transfer with VLAN capabilities. 7. Explain static routing versus dynamic routing. Static routing involves manually configuring routes on a router, specifying paths for data to specific destinations. It's simple, secure, and suitable for small, stable networks, but doesn't adapt to changes. Dynamic routing uses protocols, e.g. OSPF, BGP, to automatically discover and update routes, adapting to network changes like failures. It's scalable for large networks, but requires more resources and configuration. Static routing offers predictability, while dynamic routing ensures flexibility and resilience. 8. What are the differences between RIP, OSPF, and BGP? RIP, Routing Information Protocol, is a distance vector protocol, simple but slow, using hop count max 15 for small networks. OSPF, Open Shortest Path First, is a link state protocol, scalable and fast, using cost metrics for large networks with rapid convergence. BGP, Border Gateway Protocol, is a path vector protocol for interdomain routing, managing internet-scale networks with policy-based decisions. RIP is outdated. OSPF suits enterprise networks, and BGP is ideal for ISP connectivity. 9. What is VLAN and why is it used? A VLAN, Virtual Local Area Network, logically segments a physical network into separate broadcast domains without additional hardware. Devices in different VLANs cannot communicate directly, enhancing security and reducing congestion. VLANs are used to isolate traffic, e.g., guest versus employee networks, improve bandwidth efficiency, and simplify network management. Configured on switches using tags 802.1q, VLANs enable flexible network design, reduce broadcast traffic, and support scalable, secure network architectures in enterprises. 10. What is STP, Spanning Tree Protocol, and how does it prevent loops? STP, Spanning Tree Protocol, prevents network loops in Ethernet networks with redundant paths. Loops can cause broadcast storms, crashing networks. STP, defined by IEEE 802.1d, elects a root bridge and calculates the shortest paths, placing redundant ports in a blocking state. It monitors topology changes, dynamically adjusting to maintain a loop-free path. If a link fails, STP activates blocked ports, ensuring connectivity while preventing packet duplication and network instability. 11. What is a firewall and how does it work? A firewall is a security device or software that monitors and controls network traffic based on predefined rules. It acts as a barrier between trusted and untrusted networks, filtering packets by IP, port, or protocol. Firewalls can be stateful, tracking connection states, or stateless, inspecting packets individually. They prevent unauthorized access, block malicious traffic, and enforce security policies. Modern firewalls also support deep packet inspection and application layer filtering for enhanced protection. 12. Explain the difference between IDS and IPS. IDS, Intrusion Detection System, monitors network traffic for suspicious activity, alerting administrators without blocking traffic. It's passive, analyzing packets for known attack signatures or anomalies. IPS, Intrusion Prevention System, actively blocks malicious traffic by dropping packets or resetting connections, sitting in line with the network. IDS is detective, aiding post-incident analysis, while IPS is preventive, stopping attacks in real time. Both use similar detection methods, but differ in their response to threats. 13. What is VPN, and how does it ensure secure communication? A VPN, Virtual Private Network, creates a secure, encrypted tunnel over the Internet, connecting remote users or networks to a private network. It ensures security using encryption protocols, e.g. IPsec, SSL/TLS, to protect data confidentiality and integrity. VPNs authenticate users/devices, preventing unauthorized access. By masking IP addresses, they enhance privacy. Common uses include secure remote work and bypassing geo-restrictions. VPNs rely on protocols like OpenVPN or L2TP for robust, secure communication. 14. What are common network attacks, DDoS, MITM, phishing, and how can they be mitigated? DDoS, Distributed Denial of Service, floods servers to disrupt service, mitigate with traffic filtering or rate limiting. MITM, Man in the Middle, intercepts communications, use encryption, HTTPS, TLS, and VPNs to prevent. Phishing tricks users into revealing credentials. Counter with email filters, user training, and two-factor authentication. Additional defenses include firewalls, IDS/IPS, and regular patching. Monitoring tools like Wireshark help detect anomalies, while network segmentation limits attack spread. enhancing overall security. 15. What is port security and how is it implemented on switches? Port security restricts switch ports to authorized devices by limiting MAC addresses allowed to connect. It prevents unauthorized access and MAC flooding attacks. Implementation involves enabling port security on a switch, setting a maximum number of MAC addresses, and specify allowed MACs, static or dynamic. Violation actions include shutting down the port or sending alerts. For example, Cisco switches use commands like switchboard port security to configure and enforce these restrictions effectively. 16. What are the key differences between 802.11a/b/g/n/ac/x? 802.11a uses 5 GHz, offering 54 megabits per second less interference. 802.11b uses 2.4 GHz, up to 11 megabits per second, longer range. 802.11g, 2.4 GHz, 54 megabits per second, improves speed over B. 802.11n, 2.4/5 GHz, up to 600 megabits per second, introduces MIMO for better performance. 802.11ac, 5 GHz, up to 1.3 gigabits per second, enhances speed and capacity. 802.11ax, Wi-Fi 6, 2.4/5 GHz, up to 9.6 gigabits per second, adds OFDMA, improving efficiency, range, and multi-device support. 17. How do you troubleshoot a slow network connection? To troubleshoot a slow network, check physical connection for loose cables or faulty hardware. Test bandwidth using tools like iPerf. Verify network congestion with monitoring tools, e.g., SolarWinds. Check for high latency or packet loss using ping/traceroute. Inspect device configurations, DNS, MTU settings. Scan for malware or unauthorized devices. Update firmware/drivers and optimize QoS settings. If wireless, check signal strength and interference. Document findings, isolate issues, and test after each change to confirm resolution. 18. What tools do you use for network monitoring and troubleshooting? Common tools include Wireshark for packet analysis, capturing and inspecting network traffic, ping test connectivity and latency, traceroute maps packet paths, identifying routing issues, Netstat displays active connections and listening ports. SolarWinds or Nagios provide comprehensive network monitoring, alerting on performance issues. MapScan for open ports and devices. iPerf measures bandwidth and throughput. These tools help diagnose connectivity, performance, and security issues, ensuring efficient network troubleshooting and management. 19. How would you diagnose and resolve a DHCP issue? To diagnose a DHCP issue, verify the DHCP server is running and reachable using ping. Check client connectivity and IP assignment with IP protocol configuration, Windows, or ifconfig Linux. Ensure the DHCP scope has available addresses. Inspect server logs or errors or conflicts. Use Wireshark to capture DHCP packets, confirming requests and responses. Resolve by restarting the DHCP service, expanding the scope, fixing misconfigurations, or addressing IP conflicts, then test client connectivity. 20. What is latency, jitter, and packet loss, and how do they affect network performance? Latency is a delay in data transmission, impacting responsiveness, e.g., slow web loading. Jitter is the variation in latency, causing inconsistent performance in real-time applications like VoIP. Packet loss occurs when data packets fail to reach their destination, leading to retransmissions and degraded performance. High latency slows applications. Jitter disrupts streaming or calls, and packet loss reduces reliability. Mitigation includes optimizing routing, prioritizing QoS, and upgrading bandwidth to ensure smooth network performance. 21. What is MPLS and how does it work? MPLS, multi-protocol label switching, is a high-performance routing technique for directing data across networks. It uses labels to make forwarding decisions, bypassing complex IP routing tables. Packets are assigned labels at the ingress router, and intermediate routers switch them based on these labels, improving speed and efficiency. MPLS supports traffic engineering, QoS, and VPNs, commonly used in enterprise and ISP networks for reliable, scalable, and prioritized data transmission across diverse protocols. 22. Explain QoS quality of service and its importance in networks. QoS quality of service manages network traffic to ensure optimal performance for critical applications. It prioritizes specific data, e.g., VoIP over email, using techniques like traffic shaping, bandwidth allocation, and packet prioritization. QoS reduces latency, jitter, and packet loss, ensuring reliable performance for real-time services. It's crucial in congested networks, preventing bottlenecks and enhancing user experience. In enterprises, QoS supports mission-critical applications, improves efficiency, and ensures consistent performance across diverse traffic types. 23. What is NAT and what are its different types, static, dynamic, PAT? NAT, Network Address Translation, maps private IP addresses to public ones, conserving IP space and enhancing security. Static NAT assigns a fixed public IP to a private IP, used for servers. Dynamic NAT maps private IPs to a pool of public IPs, suitable for temporary connections. PAT, Port Address Translation, maps multiple private IPs to one public IP using unique ports, ideal for home networks. NAT hides internal network structures, improving security. 24. What is SDN, software-defined networking, and how does it differ from traditional networking? SDN, software-defined networking, separates the control plane decision-making from the data plane packet forwarding, centralizing network management via software. Unlike traditional networking, where devices, routers/switches, independently handle both planes, SDN uses a controller to dynamically configure networks, improving flexibility and scalability. Traditional networks rely on static, device-specific configurations, making changes slow. SDN enables automation, rapid provisioning, and centralized monitoring, ideal for cloud and data center environments, reducing operational complexity. 25. What is VXLAN and why is it used in data centers? VXLAN, Virtual Extensible LAN, is a tunneling protocol that extends Layer 2 networks over Layer 3 infrastructure using UDP encapsulation. It supports up to 16 million virtual networks, overcoming VLAN's 4096 limit. In data centers, VXLAN enables scalable multi-tenant environments, allowing virtual machines to communicate across physical networks. It supports workload mobility, simplifies network segmentation, and integrates with SDN for dynamic provisioning, making it ideal for large-scale, cloud-based data center architectures. 26. A user cannot connect to the internet. Walk me through your troubleshooting steps. First, verify physical connections, cables, Wi-Fi signal. Check the device's IP configuration using IP protocol configuration /ifconfig. Ping the default gateway and external sites, e.g. 8.8 to 8.8, to isolate connectivity issues. Verify DNS functionality, try and lookup. Restart the modem/router and device. Check for IP conflicts or DHCP issues. Inspect firewall or security software settings. Use traceroute to identify routing failures. If unresolved, contact the ISP. Check for outages and review router logs or errors. 27. How would you configure a router for a new branch office with redundant links? Configure the router with IP addresses for each interface, LAN/WAN. Set up redundant links using dynamic routing protocols like OSPF for automatic failover. Assign static IPs or enable DHCP for LAN devices. Configure NAT for internet access. Implement QoS to prioritize critical traffic. Set up VPNs for secure interoffice connectivity. Enable firewall rules to restrict unauthorized access. Test failover by simulating link failures, ensuring seamless switching. Monitor with tools like SolarWinds for performance. 28. What steps would you take to secure a corporate network? Implement strong passwords and two-factor authentication for devices. Deploy firewalls and IDS/IPS to monitor and block threats. Use VLANs to segment sensitive data. Enable encryption WPA3 for Wi-Fi, IPsec for VPNs. Regularly update firmware and patch systems. Configure port security on switches to limit MAC addresses. Use ACLs to control traffic. Conduct regular security audits and penetration testing. Train employees on phishing awareness. Monitor network traffic with tools like Wireshark to detect anomalies promptly. 29. How you handle a network outage with minimal downtime. Identify the outage scope using monitoring tools, e.g. Nagios. Check physical connections and power. Verify router/switch configurations and log for errors. Use redundant links to reroute traffic, e.g. via OSPF. Restart affected devices if needed. Test connectivity with ping/traceroute. Communicate with stakeholders about status and ETA. Apply temporary fixes, e.g. static routes, if necessary. After restoration, analyze root cause using log/Wireshark. Implement permanent solutions, and update disaster recovery plans to prevent recurrence. 30. Describe a challenging network issue you resolved in your previous role. In a previous role, a corporate network suffered intermittent outages due to a broadcast storm. Using Wireshark, I identified excessive ARP requests from a misconfigured switch. I isolated the faulty switch, enabled STP to prevent loops, and updated its firmware. I also implemented port security to limit MAC addresses and VLANs to segment traffic. Postfix, I monitored the network with SolarWinds, ensuring stability. The solution reduced downtime and improved network reliability significantly. Master your network engineer interview with our top 20 questions and answers, offering in-depth insights to showcase your expertise. Stay confident, prepared, and ready to excel in your next career opportunity.